Perfect. AgroIntelli is a Danish development house, or it's a Danish development house who is under a kind of transition from development to production and sales. The company is established in 2015, but in 2019 there was made a new strategy that was more related to our product called Robotti. This translation or transition we're in is expecting that we are going from around 24 employees in 2019 till around 200 in 2024. That's in my own presentation I have a question mark to the 200 because that's depending on how the market is developing. My main work area is have been and is still to create sales and to be commercial and to be talking to farmers in the fields and finding out what's the next step and what's giving value for both farmers and producers of robotics. And my main responsibility from 2 months ago is to get a service up running with robotics in Denmark. That service we call Robotti as a service, and it's one of 3 go-to-market strategies. The 2 others is in Scandinavia, especially Denmark, Norway, Sweden, to sell direct to customers and do the service with the customers. That this is something we'll do ourselves. And then we have another strategy for Europe and a little bit later global-wise, that we need to partner up with service partners and dealers in a more normal way of thinking sales. Our vision is, with all what we're doing, is to be a part of doing global production of food more reliable and sustainable, but also all the time with money for the farmer. We need to find out where the value is for the farmer and where the value is for the food production. So we keep on thinking in money-wise production of food. In Denmark, there is a kind of movement to local produce food, and I'm very keen on that idea. But I'm very aware of that we in Denmark export around 85% of our food production to other countries than Denmark. So local have to be smart also. But that we will really like to participate in. When we look into why we are doing what we're doing with Robotti, the main drifting have been to avoid this kind of fields in the future. Where the idea about making an autonomous robot is that if you have a light-weighted machine but with a capacity that's high enough, you can probably do it in an economy thinking way with a autonomous machine, because you don't have to rely on your payment to the worker on the tractor. I think there's a lot of development in farming and sizes of machinery that the reason why it's driving and getting bigger and bigger is that the guy on the tractor need a higher and higher salary. And also now we see that somewhere there's problems in finding people to drive the tractors. We see the challenge we try to face with Robotti is that we need people to do work, and it's the lack of workforce is getting bigger and bigger for the farms. I thought it was something connected to Denmark and high value countries, but we also get calls from Ukraine, Brazil, China, who have the same problems with workforce and I think it's especially for these these work where you have to do it again and again, and the picture here is showing very precise what we mean. In pesticide thinking and in spraying thinking, we have increased problems with what's that called, resistance of chemicals. We also have a need of more production of food and food for animals. We have a higher and increased demands for the security of what we're doing, and in general, we have to do it cheaper and cheaper. Per produced kilo. It's not necessarily cheaper to buy the machinery, but it has to be cheaper what you produce. The idea about logging what we're doing is something we believe in the developed countries in the world. There'll be a kind of a license to produce as a farmer. So if you're going to use chemicals in the future, you also have to be documenting very precise what you're doing. My personal opinion is that in a sustainable way, maybe we should be very aware of where we use the pesticides, but we still use pesticides because they still have a possibility to do the sustainable thinking more efficient. As I see it, it's extremely difficult to control weeds in different crops, and these weeds, maybe with a very small amount of pesticides, it would be easier to control. But then we have to leave the way we do it today, where we just spray everything. For the soil compaction that have been the driver for Robotti, the most of the development time is here. What you can see what happens when you do soil compaction, you get a less healthy soil, and it's difficult for the roots to find water and to find air to grow from. What we are out with here in Denmark is this, or the one we are on the market with right now. We are in the market in 9 European countries. We are ready to run. We are ready to run demos with 9 different robots in all over Europe. So we are ready to execute demos for customers. We have sold one Robotti in Netherlands for an end customer, and we have been doing a lot of performance testing, especially in Denmark, but even more in Czech Republic, where we have sold 5 robots to our dealer in Czech Republic, but he has not sold it for end customers yet. But he's also doing a kind of a service this spring. He only have 2 robots right now in his to run with, and because the 5 is sold from a thinking of when they work, they have bought them. So he'll do the demos in the Czech Republic on 600 hectares. But in this autumn, we seeded around 400 hectares of winter rape with the robot you can see here. And we have a capacity on one robot with 6 rows on a single seeder. There we have a capacity on 1.2 hectares per hour. And the machine is running on diesel, and it's with a 3-point hitch in the middle. And it's with the PTO, and is with 3 different hydraulic outlets. In the modules you have in the right side, you have a motor running the PTO and the hydraulics, and in the left side you have a motor running the forward running and the steering and the lifting of the 3-point hitch. All in all, we have 150 horsepower on this machine. 75 horsepower in each side. The motor is from Kubota, and all the hydraulic components on the machine is standard components that you can buy in the local blacksmith store. And that's something we believe in. Is very important that we keep robots in, so the parts on the ground is possible to be serviced as quick as possible, and also that we can use the setup that the tractor dealers have today, so it's not difficult to get service to your machine whatever and wherever you are in the world. The navigation system on the robot is very similar to a tractor navigation, and it's just a little bit evaluated from a tractor navigation system, so the robot can find its way around the field. The field is marked with a drone, or you can even do it with the robot. That's a little bit difficult, but we need a field boundary to do the marking of the field. But when we have the field boundary, and if there's any obstacles or directions we need to force the robot to do, then the robot do the rest of the optimization. And in different tests, we are in a level of 8 to 10% more efficient in the route length when we run around the field with a robot. That's a little bit theoretical discussion, because when we run in sugar beets, we also need to do what you're used to do, so it's easier to row clean them. In Denmark, we have decided to run on clean biodiesel on these robots. So already from spring on the 4 robots, we are going to save 65% of the CO2 in running in the fields, and we are total without we are clean running only on rape oil. That's not something we sell yet, because it costs the guarantee on the robot's motor. So it's something we are testing on a high level scale this spring in our own service machinery station. When we calculate what we compare is that we take that 1 hour of work on a tractor that demands 1 tractor driver in 1 hour, and we calculate that there's a 4% of loss of yield when you run in a traditional tractor context, and that we compare with that 1 hour of drifting with a Robotti costs 1 hour of work power from the Robotti operator gives you a 3-hour drifting of the robot. So we don't have a level of autonomy where we say it's a robot and you can just leave it in the field in 24 hours and everything is working. No, it's something you can start and then you can let it run which task it's doing. You can go back to it and service it with 2 or 3, 4, 5, 6 hours of difference. We have proven 10% higher use of our fuel because of the special build of the machine where you have the tool between the wheels. So you have a very efficient transition of the power from the machine to where the shares are in the ground. The unique build precision, doing everything is stiff in the machinery, which means that when we run, we know where we're seating. So the next time when we row clean, we'll go in the same direction. When we do bench spraying, we'll go in the same direction. So there's nothing mysterious or high level thinking in the technology here. There's no camera technology, anything. It's just that when you know where you have seen the thing in rows, you can also be very precise with your bench sprayer and you can be very precise with your row cleaner. And that's what we're going to showcase this spring in Denmark. We have been testing, of course. We did seeding. What the pictures from here is from, or the video from here is from 2019, where we did it in Denmark on 2-hectare fields, and there we saved 62% of the chemicals by bench spraying. Just bench spraying over the sugar beets, and no mysterious solutions, just old kind of handcrafting. We see a customer that's between 30 to 45 years, and don't really matter if it's a buyer of the robot or it's a buyer of the Robotti as a service. We see this solution for global arable farming. We see this solution as where you need some kind of education in farming and economy. We see that there is a need of income earning, and there is a need of a sustainable production of food. we see that the biggest challenge that this customer have is the lack of workforce, or in some areas of the world also the quality of the workforce. Because if we need to get the handcraft back again, and we can't save ourselves with chemicals and pesticides, then and we have to be more sustainable, then you also need to be a better handcrafter. We have a goal of when we have the 4G Wi-Fi in the field running with 2.5 centimeters of precision. It's not so difficult to see that there's coming some values by that. And that goal is that we will do the decision making. The management will be a lot more data driven than it has been until today. Today, there's a lot of farming done from what you can remember as a farmer, not done from historical data and how did the sugar beet field perform here 5 years ago when you are in your crop rotation. So our goal is to do the big data thinking into it. But right now, the goal is to get this mechanical setup to work in the fields and do tasks we normally do, but just do them a little bit better with the robot. And the way to do it is by keeping on arable farming and look into each chain of the value chain, so that the farmer, they increase their earning by doing things a little bit better, save some money somewhere, but also do something else because they have a autonomous robot that can do something in another way. We have the market strategy. If we should talk a little bit more about that, you can see which countries we are in now in this map. This is a screen dump from our homepage. So you can just go to agrointelli.com and you can see the screen dump. But this is where the robots are located right now. Inside the next 3 months, there'll be 4 robots more in Denmark. And we are also very close to have a dealer agreement in Germany and in France, and in the UK we have made a dealer agreement. And this is where we are going to concentrate on execution this spring, because we are pretty convinced that we have to show the market how to do it before we can sell more than 1 robot to a dealer or 2 robots to a dealer. We have a range of robots in universities around Europe. We are right now participating with around 19 universities in the world, and we have 6 to 8 robots running on different kind of universities around in Europe, and we also see that as a customer for our future. So we also have some setups where we can do science setup for universities and plot execution in our route planning, but that's not so interesting for you right now. What we run with in Robotti as a service this year is that we use a 110 horsepower tractor. Is used for logistics to move the robots between fields, out of that, we have 2 robots to be ready to run in the fields. The idea about using a tractor is it take care of the headlands and they take care of wet areas or sloppy fields or something like that, and the robots do all the straight lines. That's the idea, is to simplify how to do it first, and then as the development of the robot is going forward, we can do more and more difficult areas and difficult things. What we're going to launch this spring is a robot that can turn on its own axis on the field, so we can do all the headlands without making reversing on the robot. And the reversing is a big challenge for safety, and that's why we're trying to avoid that. What we're offering is seeding, row cultivation, spraying in spinach, rowing sugar beets, cereals, horse beans, and maize. And in the autumn, we're going to present a solution for Danish farmers also for seeding and weeding of winter rape and cereals. And we probably also get developed a no-till seeder for Robotti this autumn that we're going to test in the autumn for Danish farmers. If this Robotti as a service is going to be a good idea for us as a business, we have to be aware of to have a very long season for these robots we're running with. The ambition is that each service setup have 20 robots in its portfolio, so that you have this kind of flexibility in the market and in the season. And so the 4 is only to get up running and see what's possible and to get some data. What we're looking into is that that you have to invest amount of money, and you also have to take care of pretty much hectares over a year to get the money in it. This is only Danish prices, so it's not something you can use for much, but this is what is a normal pricing for a Danish farmer in his calculations. And in the left side, you can see what we have calculated into the headlines for the business. This is the standard equipment we're running with: monosim seeder, Pöttinger seeder, Gaspardo seeder, Kværnland seeder. So it's known technology we are putting on the 3-point hitch. The Smoothser row cultivator is a special developed row cultivator for Robotti, so we get a folding system, and we also get a higher capacity on the row cultivator in 2022. The sprayer is from Denmark and a Danfoil sprayer, and the special thing about Danfoil is they go with a very low amount of water per hectare when they spray in their technology, and that's very important for us, for our capacity, that we can use between 35 and 45 liters per hectare. So that means we have a very high capacity on a 500-liter sprayer. Yeah, that's pretty much what I would tell you, and I'm ready for some questions. The idea about the lightweighted machinery is there's a lot of tasks we are doing in the field today that's not necessary to do, but we're doing it because we are running with heavy machinery. We see a lot of stop cultivation in Denmark, deep soil treatment in Denmark, where it's only because we've been there with a big machine that we have to do it, and then you have to come with another big machine to clean it up afterwards. So the idea about the lightweighted machinery, if it's that, is that if you have a capacity problem, you have more machines. You don't do the machine bigger, you get a machine more. That's of course a good idea as us as a producer, as robots, but if you look into a seeding machine, the seeders we are running with is very, very cheap per meter, especially the cereal seeders from Pöttinger. They don't really cost any money. And if you buy a 6-meter seeder machine, it'll be more expensive per meter than a 3-meter machine. So it's pretty interesting if we can hit a price on the robot that's low enough, because otherwise we take the money instead of the farmer, and that's a discussion we have internally, that you cannot just put a new machine for 170,000 euros into the field every time you have a capacity problem. So it have to be leveled a little bit right. But in Denmark, we have a pretty new investigation showing that the most efficient seeder size in Denmark and that's of course something with the field sizes, but a 4-meter seeder is the most efficient seeder we have in Denmark. That's the one who have the best economy running with in the field. So everything bigger than 4 meter is just money out of the window, because you demands more technology, you need a bigger machine, but you'll never reach the level of capacity with a 6 meters machine because the field is too small in Denmark. That's of course another calculation if you are in the middle of Australia or in the United States. But if we look into European farming, there's a lot of farming a little bit like Danish farming. size-wise. And I believe that the flexibility in more machines is as important as how big capacity you have per hour when everything is optimal, because everything is not optimal. So if it's a capacity discussion, our point of view is we need to be able to build a robot cheap enough so you can buy a set more instead of doing the robot bigger. There is a mechanical security bumper around it. So on the 3 sides in the movable direction and on the side of the robot, there is a mechanical bumper in 90 centimeters height. And that one will stop everything if that's activated. So if you stand in front of the machine and on a low level control, which means it's on the machine control, then if you stand in front of it and it comes with 5 kilometers per hour into you, it will stop over 20 centimeters of distance. So what you will get is a bruise. Then we have some additional safety on a LiDAR scanner, and we are also on the go with cameras for surveillance. But the LiDAR scanner is the one that stopping slowly up to an obstacle or something like that. It's making a half moon in the front of the robot so that it is detecting if there's something in the way. But this one is not right now approved for safety because it needs Wi-Fi. And the problem is we cannot guarantee for it we normally have this safety issues is that it have to be secure all the time. You cannot have an idea about it can go wrong 1 out of a million. Then it's not approved. High level control, that's more convenient safety because it's not something counting in the safety system. Then you have remote control on your belly with a stop on where you can stop the robot. This one have a range of 200 meters, so that's also something you have to find out. You have to put it on the machine if it's running autonomous. So right now that the safety level is that if you have fenced your field, it's okay to leave it unsurveilled. If it's not fenced, you have to be in line of sight of the robot. The robot can be stopped from your tablet, from your phone, from your PC at all times. But again, it's not counting in the safety system because you need to have the Wi-Fi connection to do it. We are working a little bit with looking into if we should make a system where the robot always stops if there's not a Wi-Fi connection, because then we can use these features as safety counting into the CE marking. One of the specialities for our robot compared with a lot of our competitors are we have a CE marking on the machine. It is approved for sales on CE level in Europe. And that's where especially tractor companies will be challenged if they are going to make this very generic setup CE approved, because they can't really guarantee that nobody puts a bigger machine on it. They don't really know what's behind the tractor. We can guarantee that it'll never be more than the width of the wheels. Otherwise, you have to weld and do everything special with the machinery you put it on. So that's where one of the places where on our machine, this security bumper on 3 sides is that we can very easily point out where the dangerous area are on the robot. And that's between that 3 sides in the middle of there. That's where the implement are. That's the dangerous part of the machine. And that's very important regarding safety controls. But the rules are under construction for the legalization. There's a very high focus on how shall the legalization be for autonomous farming. And we are fighting hard to getting into the European legalization system and to explain what we are doing and not necessarily to explain our needs. Of course, that would be nice, but more that they'll not be taking decision out of no knowledge. That's how we work to try to be as transparent as possible, because this have to happen in farming, that something is running themselves in the field. It don't necessarily get into being robotic, but it have to happen, because there's no solution for running the farms if you don't do it autonomous in the future. So for me to see that it's more a question about that the knowledge have to be high enough to take the right decision in the legalization system. Yes, it's hard to compete with something very specific today, and you also know how it works. It is hard to change this mindset for the market, but I also see I've been traveling around all over the world now with Robotti and demo it in California, in Mexico, around the world, and I also see that there is a vacuum for solutions. There is some helping. I think the difficulties about market penetration is that when you go to execution on operational level, you get challenged from a lot of small problems. But if you have enough small problems, it don't succeed anyway. And as I normally say, it has to be simple enough so when the sun is shining, we are running in the field and not talking about robots. And that's pretty much my work area, is to get it to be simple enough so it's easy to use for a farmer when the sun is shining, because it cannot be an engineering product. And I think the problem about market penetration is our matureness as robot companies and not the farmers' understanding of how to run farms. So I think we have to respect the customers a lot, and that's where the lag is from the robot companies sometimes, as I see it. But I'm also a farmer. I'm not an engineer, so maybe I'm wrong. But yeah.